Hello and welcome to my second pre-recorded video for a conference. Something I am not enjoying doing, and I would really rather be face-to-face with you. I'm going to do my best. So we're talking about sequences. Today we'll just do arithmetic. I am using the TI-Nspire. You can obviously think of other ways that you could have this activity for your students. This is for beginners who are really working through that notation and the vocabulary and trying to get at some different ways to represent these sequences. So the first thing that I do is I give the kids their choice. They can kind of make up their own sequence. I won't let them all do 1, 2, 3. We're going to use 1, 3, 5 as a nice example, but sometimes I put the kids in pairs and say, okay, well, just don't start with 1. So, okay, so we start with 2. Okay, now maybe instead of adding 1 to every term, why don't you like subtract 3 from every term? I try to get them to come up with something that's just not plain simple and boring, like 1, 2, 3. So the first thing that they do with their sequence is they get a little baggie full of shapes or objects. Sometimes I give them little geometry tiles, or I usually bring in Dixie cups, plastic cups, little cubes, and then they make a physical model and take a picture of it with their phone, and they send it to their email. Okay, so now I have to go find my picture. Okay. All right. So, cups. So, one of my students chose 1, 3, 5, and that meant they didn't need too many of these cups. So, they did 1, 3, 5, took a picture, sent it to their email, and now have inserted it into the document. So, I also usually send them a skeleton document or some way to make this semi-idiot proof so that the kids are sure that they are giving me all the information that I need. Once they take the picture, then they have to explain everything about it. So this sequence goes 1, 3, 5, and so on. It is arithmetic, which means I should know what my first term is, and I should know what my common difference is. If my sequence is increasing, I will have a positive difference. If my sequence is decreasing, so maybe the partner chose to do 5, 3, 1, then they would have a starting number of 5 and a difference of -2. Sometimes that'll work out then, and the partners can kind of help each other with that. Okay, so the explicit formula. If they have it written on the board or in their notes, they should know that to find any term, they take the first term and either add or subtract the common difference, n minus 1 times. Now, this seems just very arbitrary to them. They're like, where did this formula come from? So I find that it's interesting then to do some algebra so that we can talk about this formula in another way. 2n minus 1, that sounds linear. It looks linear. So what if it was y equals 2x minus 1? That would tell me that the slope is 2. Well, here's my 2. It's a multiplier. It seems that things are increasing by 2's. The question might be, where does this -1 come from? Well, -1 would be the y-intercept of a graph of this line. And a y-intercept means it would be paired with 0. It would be 0, -1. Now, in sequences, we don't have a 0 term, or we don't usually talk about a 0 term. So sometimes I call this the ghost term. So -1 would be the ghost term that would come 4, 1, 3, 5. Do you agree? If I started at -1 and increased by 2, that's how it would go. So some students maybe want to kind of think about it linearly. Other students are just very stuck in the routine of this is the formula. It's A1 plus n minus 1 times d, and both formulas will work. Recursively, I like to tell the kids, hey, this is just like telling me, what you were thinking of in your brain. So you were thinking 1, 3, 5. How can you communicate that to me? And I would say, okay, where should I start? And you say 1. My first term is 1. Okay, I got it. So now what do I do to get my next term? Well, this notation is tough. The next term is defined by taking the previous term and adding 2. So previous term, next term. Now, we can't do that to get A1. We just have to start with A1. Because if we wanted to find A1, we would need A0. Well, there's kind of no such thing as A0, right? Okay. All right, so this is sort of cookie cutter. The kids can kind of fill this part out just using the formula and talking each other through it. Let's see if we can get this to graph. What would that look like? So if we do the explicit one first, the explicit one said first term plus d times n minus 1. All right, let's see what happens. Boom. Okay, so what do you notice? Well, it seems to be following a linear pattern, but it's not connected. Well, why isn't it connected? You don't have term 1.5. You don't have term 2.7. Matter of fact, we don't have term 0, right? We don't have that. We don't have a y-intercept like we would think. So each of these terms is generated by this formula. N represents the term number starting at 1. Okay, so you might tell the kids they can label this explicit. So this is explicit. All you need is the term number. So tell me the 99th term. Okay, put 99 in and go. All right, let's do recursive. Okay, so for recursive, we do have to tell where to start. So start at 1. Now we have to tell what to do to the previous term. So previous term plus 2. So I know this part's confusing. So instead of A, we use U. If we're wanting to enter in more than one sequence, we have to have numbering for that. So U1 and U2 and U3 and so on. Let's see if this is going to work. Boom. Okay, check it out. So this guy right here is the initial term, right? Term 1 is 1. How did I get to term 2? Well, it looks like I added 2. So does it appear to be the same line? Yeah, it's a line, but it's not connected. All right, let's see if we can try one more. All right, so I'm going to insert the other image, blocks. Okay, there it is. So let's see what this student did with the blocks. Ah, okay, so I see 4, 7, 10, or 10, 7, 4. Okay, so let's say that this student saw it as 4, 7, 10 is my sequence. All right, so Let's try to write the explicit. Okay, so to find any term, take first term and add. Seems like we're adding 3's n minus 1 times. Okay, if you don't like that, let's do the algebra and see what we get. Three n plus 1. So the plus 1 would be our 0 term, which we don't talk about. So maybe we can call it the ghost term, which isn't really there. And 3 is the slope. Kind of makes good sense. All right, recursive. Okay, to get my nth term, I take the previous term and what do I do to it? Add 3. Oh, but you have to tell me where to start. Where should I start? Oh, well, start with a first term of 4. And you'll have it. All right, let's try to graph it. Change it to sequence. Okay, so start at 4 and add a whole bunch of 3's. Boom. Oops, not a good window. There, how about that? Can you see them? Now let's see if I can do it right on top of itself. Okay, so to get the previous term and add 3, but don't just start anywhere. Start where I started. Start at 4. Boom. Look at that. Right on top of itself. Sequence U2, sequence U1, initial term. Look at that. They start at the exact same place. Isn't that cool? Cool. All right. Thank you for joining me. If you want any kind of help with this activity, feel free to email me. Here I am, HeidiRudolph95 @gmail.com. Thanks.